Here's the third part of lesson 3.3, problem solving with systems. And we have an interesting word problem here. There's two ways to come about getting this answer to this word problem. It's in Algebra 2, so they actually really want you to use systems of equations. And that's what I'm going to start with, and I will talk through another way you could use. But it says here the sum of the digits of a two-digit number is 11. The difference, so subtraction, of the number and a number obtained by reversing the digits is 45. What is the original number? So what we have here is we want to find the original number. And first thing might be, well, let's let that be our variable. But our original number is actually made of two digits. It's a two-digit number. And so what we're going to do, we need to find those two digits, and that will help us find the number. If we know the first digit and the second digit, that's going to give us our number. And I'm going to use t. I'm going to let that equal the tens digit because it's a two-digit number. And then there's the ones digit, but a 0 or a O looks like a 0, so I'm going to use the units digit. So U is going to be the units or the ones digit. And I'm going to use those two. And so my number at the end is going to be TU right next to each other. But that's not what it looks like. Or that TU is actually T times U, so we don't want to use that. Well, the first part of this is pretty easy because once we set this up, this is our tens digit and our units digit. We want the sum of the digits to be 11. So that's nice and easy. One of our equations is just going to be our tens digit plus our units digit has to equal 11. The next part can be the tricky part. So I'm going to try to kind of set it up here, but then we'll do some work over here to help us out. So the next part is saying the difference of the number and the number obtained by reversing the digits is 45. So it's telling us our original number, it says difference, minus when you reverse the digits, is going to equal 45. And so we have to figure out, well, what in the world goes in these two spots? All right, so we actually are going to go back to probably upper elementary when we used to expand our numbers. So just a real quick review, if we had the number 542, our teacher said, write this in expanded form, and we would write, well, this is 5 times 100 plus 4 times 10, plus 2 times 1. So we have 5 100s plus 4 10s plus 2 1s. Well, we are going to use this concept in this problem here. So our original number is going to equal, so here we took our hundreds digit and multiplied by 100. Our tens digit times 10 and our ones digit, our units digit, times 1. So for our original number, we want to take our tens digit and multiply it by 10. And we're going to add in our unit or our ones digit and multiply it by 1. So we're using this expanded form, and of course we don't usually leave it like this because we like to put our variable second. So this is actually 10 times t plus 1 times u, or just plus u. All right, so that is actually, this one right here is our original number. It's 10 times the 10 digits plus u, which makes sense. Our number is not 53, but if our number was 53, it would be 5 times 10, which is 50, our tens digit, plus 3 times 1, which is just 3, so 50 plus 3 is 53. So our original is 10t plus u. Well, we want to reverse the digits. So reverse digits. Reversed digits number. Well, in order to reverse the digits, we take our tens digit and put it in the units. So if we had this 53, our reverse would be 35. So we're actually taking our original units and putting it with the tens, and our original tens and putting it to the units. So when we reverse these, we actually have u times 10 plus t times 1, which ends up just over here being 10u plus t. We switched our units and tens. So this will go here. Now I should put this in parentheses because we're subtracting because it was a difference, so difference means subtraction. And now we have our two equations. This one we're going to simplify first. First one was easy. The sum of the digits was 11, so t plus u equals 11. Here we have the difference of the original and the reversed is 45. So let's go ahead and simplify this a little bit. We have 10t plus u. We're going to distribute the negative here, so this is minus 10u minus t is equal to 45. We have some like terms here on the left. 10t minus t is 9t, and u minus 10u is negative 9u equals 45. So we are going to look at this equation and this equation. So we have t plus u equals 11. 9t plus 9u equals 45. Here's something I want you to see. First, this should be a minus. So it was minus 9u. As we look at this equation right here, notice that 9 goes into each of these. So sometimes we multiply both sides by the same thing, but we could also divide this whole thing. We could divide both sides by 9. And this gives us t minus u equals 5. So now even easier, we have t plus u equals 11, and t minus u equals 5. This is set up wonderfully for elimination. So we can do t plus t is 2t. U minus u, that eliminates, equals 11 plus 5 is 16. Divide both sides by 2. T equals 8. Well, we found t. Let's come back to one of our originals. Let's come to this one. T is 8 plus u equals 11. Subtract 8 from both sides, and u equals 3. Well, what does this mean? T equals 8, u equals 3. It asks what's the original number. Well, t is our tens digit, which is 8. U is the units digit, which is 3, so the original number would be 83. We can check really quickly. If we reverse the digits, it would give us 38. And in the problem it said, well, if we subtract 83 minus 38, we should get 45. 13 minus 8 is 5. 7 minus 3 is 4. So our answer is 83. And that is the Algebra 2 way to solve that problem. I told you at the beginning, there's 2 ways to solve this. That's the Algebra 2 way. Definitely a tricky part, trying to think through this right here. But now we reviewed expanded form. This is how it works. It's 10t plus u is the original. 10u plus t is the reversed. Now, let's go back and think through this, maybe not with Algebra 2, but with some little bit of common sense here. The sum of the digits of a 2-digit number is 11. Well, we know 2 digits have to add together to equal 11. So let's not write it that way. Let's just say it's here. Our possibilities are 9 and 2, 8 and 3, 7 and 4, 6 and 5. 5 and 6, well, that's the same as 6 and 5. We can't do 10 and 1 because 10 is not a digit. So we kind of have 92, 83, 74, 65. Those are the only, not the only ones, but those are some of the options. If we reverse them, because we talked about reversing the digits, 29, 38, 47, and 56. These are the only 8 numbers, 2-digit numbers, whose sum of the 2 digits is 11. So it's one of these 8 numbers. Well, what else do we know? We know the difference of the 2 is 45. So 92 minus 29, is that difference 45? No, 92 minus 29 is 63. 83 minus 38, we actually just found that that is 45. 74 minus 47 is 27. We don't have to keep going because we just found our answer. And 65 minus 56 is 9. So we wanted the ones whose difference was 45. So there was only 8 options of digits that I would add up to 11, and then you figured out which ones give you the 45 when you take the difference. So you can get the 83 that way. So thinking through it, you can get it, but this would be the Algebra 2 way to do it. Makes you understand things with a little bit more depth.